Very good morning to all of you. Today we have to discuss one of the very important property of mean of a probability distribution. Let me state that property mean is affected by both the change of origin and change of scale. We have to prove this property. Effect of change of origin and change of scale means if all the values of the data are shifted by adding some constant number on the right or by subtracting a constant number on the left, or we can enlarge the data by multiplying with some convenient constant, or we can reduce the data values by dividing all the values by a suitable constant. That is what written here as mean is affected by both the change of origin and change of scale. Let us see first of all the mathematical proof of this property, and then we will elaborate this property by some numerical examples. Okay, so let x be a discrete random variable taking values x1, x2, so on xn with probabilities p1, p2, so on pn respectively. That means here we assume that x is a discrete random variable and it takes n distinct values with probabilities. That means here we have taken p of x as PMF of random variable x. Then mean of a random variable x, as we have defined already, expected value of x is summation pi into xi, I running from 1 to n. मीन ज्यावेळेला आपण कॅल्क्युलेट करतो त्याला रँडम व्हेरिएबलच्या प्रत्येक व्हॅल्यूला त्याच्या प्रोबॅबिलिटीनी मल्टिप्लाय करतोय अँड वी ॲड ऑल प्रॉडक्ट्स आणि त्या सर्वांचे आपण काय करतोय ॲडिशन करतोय. दॅट इज सिम्पली mean of a random variable x and it is denoted by e of x. Let us consider the transformation. तर रँडम व्हेरिएबल y वरून आपण दुसरा एक रँडम व्हेरिएबल डिफाईन करणार आहोत अँड दॅट इज y, अँड y इज डिफाइन्ड ॲज y इज इक्वल टू x मायनस a डिवायडेड बाय h, where a and h are any arbitrary constants. म्हणजे काय तर a आणि h आपल्या सोयीने त्याच्या व्हॅल्यूज आपण निवडू शकतो. If we take a as some negative number, then data will be shifted on the right. If a is taken as some positive number, then data will be shifted on the left. Similarly, if we take h as a number greater than 1, then it will reduce original data into smaller numbers, and if that h is less than 1, that means some fraction in between 0 to 1, then data will be expanded. We will get values larger than the original values. So, is there any thumb rule to choose A or H or both? There is no such rule for how to select A and H. These two constants, A and H, are arbitrary constants. That means we can choose any values, but in the analysis we preferably choose A and H so as to simplify the numerical computations. म्हणजेच ए आणि एच हे आपल्या सोयीने आपण निवडू शकतो. Then inverse transformation is given by x is equal to a plus h into y. Okay, so let me come back to mean of random variable x. त्या फॉर्म्युलाकडे मी परत जातो. Expected value of x is nothing but summation pi into xi. Okay, so in the place of xi, now let me plug the value obtained from inverse transformation, that is a plus h into yi corresponding to xi, we will get yi. Okay, so summation pi a plus h into yi. Now we can distribute the summation sign, but a is a constant, h is a constant, it can be taken outside the summation sign. So what we get is capital A into summation of pi, but we know since px is a probability mass function, therefore its sum is 1. So A into summation of pi, it becomes simply A plus h into summation pi into yi. Okay, now look at the second term of the expression, h into summation pi into yi. Now this is the formula of every value of y is multiplied by its probabilities, and we add all such n products, that is nothing but expected value of y. So what do we get? Expected value of x is equal to a plus h into expected value of y. So here we express mean of x as a function of mean of y. We know the values of a and h because we have chosen that. So it is known to us. Therefore, if we know the value of expected value of y, we can compute expected value of x. So here you can see both A and H, they are there in the expression. That indicates that mean is affected by both change of origin and change of scale. Okay, so ॲनालिसिस करणाऱ्या प्रत्येक व्यक्तीने वेगवेगळा ए आणि वेगवेगळा एच निवडलेला असेल तर दे विल गेट डिफरंट मीन व्हॅल्यूज ऑफ व्हेरिएबल वाय, but same value of variable x. So mean of variable y depends on which values are chosen as a and h, and hence we can say that mean is affected by both change of origin and change of scale. तर आता ही जी प्रॉपर्टी आहे मॅथमॅटिकली आपण पाहिलं त्याच्यामध्ये ए आणि एच येतोय, त्याचा अर्थ दे आर अफेक्टेड बाय चेंज ऑफ ओरिजिन अँड चेंज ऑफ स्केल. पण व्यवहारामध्ये ह्याचा वापर करत असताना ही प्रॉपर्टी आपण कशा पद्धतीने वापरणार? सपोज माझ्याकडे एक असा डेटा आहे की ज्याच्यामध्ये खूप मोठे ऑब्झर्वेशन्स आहेत. साहजिकच आहे, खूप मोठे ऑब्झर्वेशन असतील तर त्याचे ॲडिशन करणं, त्याचं प्रॉडक्ट करणं हे काम जरा क्लिष्ट होईल, अवघड होईल. मग मी काय करणार, त्याचं चेंज ऑफ स्केल करून त्या व्हॅल्यूज मी रिड्यूस करू शकतो. किंवा माझ्याकडं अशा प्रकारचा डेटा आहे की ज्याच्यामध्ये खूप लहान व्हॅल्यूज आहेत, म्हणजे उदाहरणार्थ 1.2 इंटू 10⁻⁵. सो इट इज अ व्हेरी स्मॉल नंबर. अशा केसमध्ये सुद्धा आपल्याला प्रॉडक्ट्स करणं, ॲडिशन्स करणं हे थोडं अवघड होतं. मग अशा केसमध्ये वी कॅन एक्सपांड दॅट व्हॅल्यू. So if we multiply that number by 10⁻⁵, then we get number as 1.2 only. Okay, so we can use this property smartly to reduce our time and the efforts required to perform the calculations. Okay, so this is one of the important property. You have seen this property for descriptive data in the last semester also, but here this property is in the context of priority distributions. So there comes pi. Okay, so let us see few of the numerical examples. If expected value of x is equal to 5, so we are given mean of variable x. Then what will be the mean of expected value of x minus 5 divided by 2? So here this is a transformed variable आणि या केसमध्ये ए ची व्हॅल्यू आहे 5 आणि एच ची व्हॅल्यू आहे 2. So we can write this as 1/2 can be taken outside. Expected value of x minus 5 being a constant. So expected value of x is 5 minus 5, it is 0. Or expected value of 2x plus 3. So 2 is taken outside. Expected value of x plus 3. So it is 2 into 5 plus 3, that is 13. Or expected value of x minus 2 divided by 3. So it is 1/3 taken outside. expected value of x minus 2. So it is 5 minus 2, it is 3. 3 divided by 3 is a 1. Expected value of 5x. Here the value of h is 1 upon 5. So its mean is 5 into expected value of x. So it is 25. So originally mean is 5. If we change the scale 5 times, म्हणजे प्रत्येक व्हॅल्यू आपण जर 5 पट केली तर त्याचा मीन पण 5 पट होणार. 5 5 into 5 25. एक्सपेक्टेड व्हॅल्यू ऑफ एक्स अपॉन 15. प्रत्येक व्हॅल्यूला आपण 15ने डिवाइड केलं तर व्हॉट डू वी गेट? मीन ॲज 1 divided by 3. So mean is reduced. So we can use this property smartly to reduce the efforts required to compute mean of transformed variable. तर आता तुम्ही इथं काय लक्षात ठेवायचं आहे, तर ह्याच्यावरती ऑब्जेक्टिव्ह टाईपचे क्वेश्चन्स विचारले जाऊ शकतात. जसं की आता विचारलं आहे, इफ एक्सपेक्टेड व्हॅल्यू ऑफ एक्स इज इक्वल टू 5, which of the following is the mean of 5x, y is equal to 5x. तुम्हाला त्याचा पर्याय बरोबर लिहिता आला पाहिजे. ओके, सो today we have discussed very important property of mean, and that is mean is affected by change of origin and change of scale, and we have seen some examples based on it. I think it is enough for today's lecture. We'll stop here. Thank you for listening this video lecture. See you again.